Okay, guys, this is section 9.4. We're going to talk about some real numbers today. And guys, I'm going to draw a little picture up here. First off, we have the count. Oh, hang on. All right. First off, we have the counting numbers. Okay, and that's 1, 2, 3, right? 4, blah, blah, blah. All right. And then outside of that, we've got what's called the whole numbers. And that's 0, 1, 2, 2, 3, dot, 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 forever. All right, and then outside of that, we've got the integers. Okay, and the reason I'm putting it this way is because all counting numbers are whole numbers. All whole numbers are integers. Okay, integers are dot, 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 -2, -1, 0, 1, 2, dot, dot, dot. Okay, and then the last, well, not the last thing, but I'm going to put right here, these are called the rational numbers. Okay, these are numbers that can be written as fractions. So things like -1/2, 0, 1.2, 4. Okay, those are all numbers that can be written as fractions. But then out here, it's not included in all that stuff. These are the irrational numbers. These are numbers that cannot be written as a fraction. Okay? Irrational numbers cannot be written as a number over another number. All right? Now, this entire group, okay, you know what? I should do this. I should actually write this with a different color circle around it. How about that? I'm going to put it out here. Irrational numbers, like pi and √2. Okay, and then I'm going to put all of these in a big green box, and this big green box is known as the real numbers. Mr. Cortez, that means we must have some non-real numbers. We do. We'll talk about that later. The imaginary numbers are the complex numbers, but the real numbers are like this. Okay, now today I want to focus on irrational numbers. Now, the way we can tell irrational numbers is we look at the decimal form. Okay, decimals can do one of three things. They can repeat. Okay, and if they repeat, they're rational. For example, 1/3 is equal to 0.33 repeating, right? Okay, the second thing they can do is they can terminate or end. That's what terminate means. Okay, such as 3/4, which equals 0.75, and then there's nothing behind the 5 but zeros. It's kind of a repeating number too. It's just repeating zeros. And then the third thing that happens is non-repeating. That means that the decimal never ends, but it also never repeats. Okay, for example, I'll put in here √5. Okay, that's in parentheses. Now, these are rational. This one is irrational. Okay, Mr. C. So that means that the square root of 5 can't be written as a fraction. That's true. Okay? It cannot be written as a fraction. Neither can pi. There's no number divided by another number that equals that. It just goes on forever and ever. All right? Now, there's one other note that I want us to make here, that if you take the square root of a whole number and I'll put in parentheses square root 13, and it does not equal a whole number, then it is irrational. You can always, if it doesn't come out to a perfect number and end, then it's irrational. All right? Okay, guys, I'm going to have to let you go, and I'm going to look for you at the first example, but I think we got a lot of stuff done there. All right? Good job.